All right, so now the tester can do 2 cells at once. And apologize, the lighting is really terrible. It's like 3 o'clock in the morning, so I've just got some little shop lights here. It turns out I didn't have all of the parts I needed, but I was able to kludge it together with 2 MOSFETs that were kind of pushing pretty hard, and so I put them on a fairly large heatsink here, and then I have a fan that turns on whenever we're discharging here. But it's basically the same setup we had before. I did match the impedance. This one is 41.7 milliohms, and this one is 41.9, and that's at the cell level. So what I did is I stuck an inline current shunt here, and then I measured the voltage here, and I did both of the cells. And so one of them was 41.7 milliohms, and the other one was 41.9. So that's with less than 1% matched. And so our assist, which is what these big hunk of cables are doing, is going to be balanced to within less than 1%. The regen side, I was 1 cable short. So these have a daisy chain in the back. So basically this Mac Mini is hooked up to this first one via USB, and then none of the other ones have USB, so there's actually a RS485 connection, and you daisy chain it. And I was actually 1 cable short, and it is just RJ45, but I don't actually have an RJ45 crimper anymore, so I need to borrow one or whatever. But all that means is that the first cell regens at 75 amps, and the second one can only regen at 52.5 amps. So we'll switch the cells up. I mean, ultimately there's a bunch of different tests I want to do. So, we can do high current tests on this one, and then we can do the still pretty high current, 51 amps at 4 volts. It's quite a bit of power or whatever. But anyway, they're all addressed, address 3, 4, 5, and 6, so I can talk to them. And so now I just need to modify the code slightly, and then I'll be able to do both of the modules. But you can see here on this second guy here, I'm going to just manually turn this on, and you can see that the fan turns on, and we're actually discharging right now. This only gets up to about 70 degrees C. It's rated for 175 degrees C at the junction. It's rated for, I think, 125 at the case, and that's what we're actually measuring. So we've got 50 degrees of margin. It is nighttime, so we're going to lose some of that. We're going to be pushing this pretty hard here, and I mean, whatever, if it blows up, then I'll get the proper FET. And then once again, I have it just mounted using extra parts I had lying around. This is actually just a loose piece sitting inside of another one, but it works pretty well, and it'll do the task here. But it is getting a little bit clustered here. Certainly, if you were testing more than 2 or 3 cells, you would want to do this a little bit better. But anywho, that is the test setup here. So we'll be able to start testing the EHW5 modules. We'll resume the testing here, which has been paused. We've done 90 cycles on this battery now, and this one, of course, we haven't done any on. This is my sacrificial. This is the EHW5 module that I use to make the 12S, I'm sorry, the 18S to 12S conversions. So I don't really care about these cells, and of course I have the 6 cells that I took out. So eventually, once I trash some of these cells, which this test is going to trash these cells, then I'll just swap out the ones that I have that I took out previously. So this will be perpetually a 12S pseudo module, or pseudo 12S model, I guess is what we call it. And we'll be able to trash 6 cells and then replace them with the other ones that we have sitting on standby. So anyway, that is the second test. So we can now test in parallel. These tests they could possibly take months. And so having a second test is going to save us quite a bit of time. In fact, if we were to get 50,000 cycles on this one, it would take half a year. It was like 182 days or something. I don't think this cell is going to last 50,000 modules. I'm sorry, 50,000 cycles at 90, 85 amps discharge, and then 52.5 amps regen. I think that's going to trash it pretty quick. I think the 50,000 cycle life is probably at like 1C or less. Although I don't know how the heck you would test that. It would take forever. Maybe they're using models or something. Anywho, this is, oh, you know what, actually I do know, it was a continuous 40 amps charge and discharge. So I do remember that now. And so now we're going to be doing 52 amp charge and, between 80 and 90 amps discharge, again, because we're discharging through this resistance, 41.7 milliohms. When it's at 4.1 volts, it might be 95 amps, and then at, 3.3 volts or whatever, it might be, I don't know, 80 amps. I don't do math in my head, as I've said several times. Anyway, that's the new tester. seems to be working pretty well. So yeah, this is an odd front porch thing to come across here with these 4 Lambda gens just sitting here running full time. And our test setup is, it's getting to be pulling quite a bit of power. The idle power on just the 120 volt section of this right now, the way you look at it, is 100, I don't know, it's only 73 watts now. So that's nice. It was 100 watts earlier, I guess, when the Mac Mini first turned on. You know, whatever, it's going to cost 25 cents a day just in the standby power to run this. And then, of course, we'll actually have our test currents as well, which, you know, we're looking probably at, I don't know, 25, 30 bucks a month in power to test these, which is ultimately nothing. So anyway, as always, thanks for watching. I know that lighting is horrible, but whatever. This is not a beautiful project.